about if I wanted to go from names to formulas? What we have been doing is doing formulas to names. So if I gave you a name of a compound and asked you to write the formula, how would you do it? Well, first we would write the symbol of the cation. We know that the cation is just the elemental name, so that wouldn't be too hard to find. And then next we write the symbol of the anion. Then we figure out the charges of each of the ions, which we can do this by looking at the periodic table, taking a look at if there's Roman numerals, or on our polyatomic ion chart. Then we're going to make sure our charge is balanced, because remember, compounds are neutral molecules, and we're going to do this by adding atoms to each ion until the charges balance out. So adding atoms, I mean by changing the subscript here, and then finally it should be put all together. So let's do some practice. We've got potassium sulfide here. Remember, first step, figuring out the symbols for both the cation and the anion. Okay, potassium, we know that that is the cation and it's just the element's name. So if you find potassium on your periodic table, it's atomic number 19 and the symbol is K. All right, sulfide, we know this is the anion, and if it ends in IDE, we've taken off the ending, so sulfide is also sulfur, and that is atomic number 16 with the symbol S. Now, we have to look at the charges and make sure they balance. Potassium is in group 1, so that it typically has a +1 charge, so we're going to write +1 above the name. Sulfur, that's in group 16, so that typically has a -2 charge. So in order to balance these out, the easiest way to do it is add another atom of potassium to give us a +2. So we're going to have K2S. Let's try the next one. I've got barium telluride. Barium, again, that's just our element. Find it on the periodic table. It is atomic number 56, symbol Ba. Next, we need to name the anion. Telluride, remember we took off the ending, added IDE, so that means it's tellurium. Atomic number 52, symbol Te. All right, now got to figure out the charges and balance it out. Barium comes from group number 2, which means it typically has a +2 charge. Telluride comes from group number 16, which means it typically has a -2 charge. It's already balanced. We don't have to add any extra atoms. Let's try the next. Iron 2 oxide. Looks like we have a transition metal. Remember, this indicates my charge. So we already know the charge of iron. And iron, finding it on the periodic table, its atomic number is 26. Its symbol is Fe. Oxide, we've taken off the ending, named it IDE. Oxide is oxygen. Its atomic number is 8, and its symbol is O. So we know that iron's charge is +2. Oxygen, its group is 16. Typically it has a +2 charge, which means that this, or typically it has a -2 charge, which means that this is -2, and they balance out already. And for the last one, aluminum phosphate. Figuring out the symbols of each is our very first step. Aluminum, our cation, is atomic number 13 with the symbol Al. Phosphate. This is a polyatomic ion. If you remember, we've used that one a couple times already. So you're going to take a look at your polyatomic ion chart, look at the names, see if you can find phosphate, and it's in the -3 section, and its symbol is PO4. And it looks like phosphate has a -3 charge. Looking at aluminum, it's in group 13, and typically the elements in group 13 have a +3 charge. So aluminum is going to have a +3. Looks like they already balance out. We don't need to add any extra atoms. That's great. Let's do some more practice putting it all together. So I'm going to have you either writing the names or taking the names and writing them to the formula. Let's try the first one, NaCl. We need to figure out what the name is. And remember, first step, naming the cation. So find Na on your periodic table. Looks like it's sodium. All right. Cl, find that on your periodic table. Chlorine. And we need to take off the ending and turn it into chloride. Let's try the next one. Na2O. Well, Na, we already know that that's sodium from the previous example. Oxygen, that's your O there. So take off the ending, put IDE, and we have sodium oxide. FePO4. Well, Fe, that stands for iron. But notice where iron is located on your periodic table. It is in the transition metal slot, so that means we have a transition metal. So we need to figure out its charge by looking at the atoms. You notice that PO4, that's a polyatomic ion, so we need to find the polyatomic ion PO4 on your chart. Looking through, looking for PO4, you notice that it's in the -3. It's phosphate, so you can write down phosphate, because remember when we name polyatomic ions, we just use that polyatomic ion name. PO4, it's got a -3 charge. You notice there are no extra atoms of iron, so it must have a charge that balances out. So in order to balance out a -3, that means iron's going to have a +3. So our Roman numeral is going to be a 3. Okay, the next one, we've got Cu2PO42. Cu, we're going to look on the periodic table, that stands for copper. And you notice that that is also a transition metal. Well, PO4 we've used in the last example. That's phosphate. And we know that that has a -3 charge. So -3 multiplied by 2 gets us a -6. Copper, having 3 atoms, we're going to figure that out. So we're going to take 6 divided by 3. That's going to give us a +2 charge. So that means this is copper 2 phosphate. All right, let's try some more. CuF2. Cu, we already know that that is copper. F, there's only one symbol there, so that means it's on the periodic table. Finding it in the group 17, F stands for fluorine, so we're going to change that to fluoride. We know that copper is a transition metal, and to figure out which charge it is, we have to look at the charge of fluoride. And we notice that it's in group 17, which typically has a -1 charge. It has 2 atoms, so 2 times -1 gives us a -2. For the charges to balance out, copper has to have a +2 charge, so we know this is copper 2 fluoride. Awesome. Let's try this one. Looks like we need to go from name to formula. Well, remember, write the symbols for both the cation and the anion. Calcium, let's look on the periodic table. Oh, I see it there, atomic number 20, symbol Ca. Fluoride, oh, well, we used that in the previous example. We know that the symbol is F. Looking at the typical charges, calcium is in group 2, so that means it typically has a +2 charge. Fluorine, we know this has typical as a -1 charge, so to balance them out, we need to make this charge -2. That is the easiest route, so we're going to add 2 atoms of fluorine. Let's try the next name. We've got lithium iodide. Lithium, that is an element. Its atomic number 3 stands for Li. Iodide, this is iodine. Atomic number 53, symbol is I. Lithium's typical charge, because it is in group 1, is a +1. Iodine's typical charge, because it's in group 17, is a -1. So this is already balanced out. And last example on this slide is Sb2SO3 Okay, Sb, naming our cation. We're going to look and see if we can find it on the periodic table. Sb, yep, atomic number 51. This is antimony. SO3, we notice that that is multiple atoms put together, means it's a polyatomic ion. See if you can find SO3. Yep, it's in the -2 section. This is sulfite. Perfect. Let's try this one. We've got ammonium carbonate. The easiest way to go about looking for these is look on your polyatomic ion chart first if you're not sure if it's an element or not, because your polyatomic ion chart is so much shorter than the periodic table. So let's look at the chart first. Okay, I found it right away. It's in +1, so its symbol is NH4. Carbonate, we're going to look at the polyatomic ion chart first, and it is in -2 with a symbol of CO3. You notice on the chart that ammonium's charge is +1, carbonate's is -2, so we've got to balance that out by changing the +1 to a +2, so giving ammonium 2 atoms. The next one, KNO3. Our cation is the K, that is potassium. NO3, we know that's a polyatomic ion. NO3 stands for nitrate, so we have potassium nitrate. All right, CS2SO4. Okay, CS, this is cesium. SO4, we know that's a polyatomic ion, and it stands for sulfate. Perfect. Last one is copper 2-phosphate. Well, we know that this indicates that this is a transition metal, so we know copper has a +2 charge. We're going to write that down. Copper's symbol is Cu. And we know that phosphate, again, looking on the polyatomic ion chart first, and you may remember this one already because I've used it a few times. Phosphate is a polyatomic ion in the -3 slot with a symbol of PO4. Well, now we have to balance these out. Well, you've got to find a common number. The easiest way to do that is to multiply the two numbers together, and you can get a charge of +6 and -6. So 2 times 3 gives us 6. So we're going to have 3 copper atoms, and 2 times 3 gives us 6. And so the charge here is 3, so that's going to give us 2 phosphate atoms. Let's do a little recap. Remember, to name the cation, we have to use its element's name. Naming the anion, we're going to take the root word of the element and add IED. If we have transition metals, we are going to use Roman numerals to identify their charges. Naming polyatomic ions, we're just going to use their name, no name ending required. Using the periodic table to determine the charges for each element when writing the formulas will be a very useful tool for you in the future. So, this ends the lesson for today. Have a great day.